Good morning, one and all. Let me continue with the next session or video lecture, which I am going to continue with the deletion of an element from a stack. Already we have seen how to insert an element with the stack with the condition called as the stack should not be overflowed, and the top should be initially it will be -1. If I insert some element onto the stack, so your index value will be incremented from -1 to +1, that is 0. The index will be 0. So the next case for deletion is the same. How to delete an element from a stack, which I told, like delete is also called as the pop operation. For deletion, we have a array implementation here. We have a function called as pop, and initially I am checking whether my top is -1. If it is -1, there is no necessity of any deletion operation here. We will just put it as underflow. Else I need to what? I need to decrement an element from the stack. So that means stack of top is equal to top -1. So this is the procedure for deletion. And the next is we are going to see one more operation which I told in the previous video, that is called as peek operation. What is meant by peek means it will just return the top value where currently the top is pointing out in the stack. So that's what which involves returning the element which is present at the top of the stack without deleting it. Here also we need to check the underflow condition, checking that with the help of peek function, we're just going to check if top is equal to -1, and printf we are just going to check for the condition as underflow. Else I'm just going to print simply what is my current top variable. Okay, so here we will see the full program of using the case statement, case or switch case, with the help of this push operation, pop operation, and show means display, and we have peek as well. I'm just going to read a variable called as n, and here I'm going to use 4 condition. One is case 1 is push, case 2 is pop, case 3 is show, and the last option is we are just going to exit. So the case 1 is push. For push operation we have what? As I said, we are just going to check the size of the top, which is equal to n. If it is so, you should assume that your stack is full, so you should write as overflow. Else we can increase one element. We can place one more element onto the stack, like top is equal to top +1, and the index pointing out to the particular place, we can place the value of that element. And next is pop. Pop, as we saw, top is equal to -1, checking for underflow, and if it is so, yeah, I'm just decrementing top is equal to top -1. And I'm going to display what are all the elements we have inserted onto the stack. Say for example, if a stack consists of 5 elements, with the help of the push operation I have inserted all the 5 elements. Now my stack becomes full, and how I should display all the element with the help of the for loop. I'm just going to check the condition called as for I is equal to top, or I is greater than or equal to 0, I minus. If it's so, my I value will be my top value. Say for example, top is 5 now, 5 is greater than or equal to 0, condition satisfies. I'm going to print the element first called as, in the fifth index, what element is there, that will be printed, and my I will be decremented, and then I is now I becomes 4 is greater than 0, condition true, stack of 4 I'm going to print. Then I becomes 3, third value will be printed, I becomes 2, I becomes 1. When I becomes 0, Zeroth element will also be printed. When I is equal to minus 1, it will be come out of the loop, and checking that my top value is currently minus 1. Minus 1 is equal to minus 1. So my stack will become empty. That means what? We have displayed all the elements. So that's all about the array implementation of stack. We saw push operation, pop operation, peep and peek operation, and how to display all the elements once the stack is full. So the next topic, that is infix and postfix notation, we will be seeing in the forthcoming lecture video. Thank you.